Let us start with network topologies. In this lecture, we will define a network topology and we will also see different types of network topologies. The term network topology refers to the shape of how the computers and other network components are connected to each other. There are several different types of network topologies, each with advantages and disadvantages. Talking in technical terms, a network topology is an interconnection of various computers in a specific way, which includes a connection between two computers using cables. Also, the arrangement of a network which comprises of nodes and connecting lines via sender and receiver is referred to as network topology. So, let us start exploring different types of topologies. The first one is the mesh topology. In mesh topology, every device is connected to another device via a particular channel. If suppose there are n number of devices connected with each other in a mesh topology, the total number of dedicated links required to connect each other is n minus 1 upon 2. So, in the above diagram which is in front of you, we can see that there are 5 PCs. So, total number of links required to connect each PC with one another is 5 minus 1 upon 2, which equals to 10. Now, what are advantages of using this topology? Firstly, mesh topology is a robust topology. If a fault is diagnosed, it can be detected very easily. Data is reliable because data is transferred among the devices through dedicated channels or links and provides security and privacy. What are the problems with this topology? Installation and configuration is very difficult. Cost of cables are also high as bulk wiring is required, hence suitable for less number of devices. Moving on to our next topology, that is star topology. In star topology, all the devices are connected to a single hub through a cable. This hub is the central node and all other nodes are connected to the central node. The hub can be passive in nature or intelligent hub, that is an active hub. So, what are the advantages of star topology? If n devices are connected to each other in star topology, then the number of cables required to connect them is n. In the figure, you can see that there are 4 PCs. Therefore, we need 4 cables to connect those PCs to the central hub. What are the problems with this topology? If the hub fails, what will happen? The entire topology fails, right? Also, the cost of installation is high. And the major point is performance of this topology is entirely dependent upon the hub. Moving on to the next topology, that is ring topology. In this topology, it forms a ring connecting devices with its exactly 2 neighboring devices. The operations take place in the ring topology. Please listen clearly. One station is known as a monitor station, which takes place all the responsibility to perform the operations. To transmit the data, the station has to hold a token. After the transmission is done, the token is to be released for other stations to use. When no station is transmitting the data, then the token will be circulated in the ring. Now, there are 2 types of token release techniques, early token and delay token. Right now, we do not need to go into the details of these technologies. The next one is the bus topology. Bus topology is a network type in which every computer and network device is connected to a single cable. It transmits data from one end to another end in a single direction. No bidirectional feature is available in bus topology. So, if n devices are connected to each other in a bus topology, then the number of cables required to connect them is 1, which is known as the backbone cable. So, you can see in the image that bold blue line is the backbone cable and the red lines are the drop lines. What is the problem with this technology? Suppose if the common cable fails, then the whole system will crash down, right? And if the network traffic is heavy, it increases the collisions in the network. And here comes the last topology, that is the hybrid topology. This topology is a collection of two or more topologies which are described above. This is a scalable topology which can be expanded easily. It is a reliable one, but at the same time it is a costly topology. So let us have a quick recap. We saw the definition of topology, then we saw different types of topology. So now you must be able to identify which topology is used in your campus. And what's next? Since we have discussed about the topologies and definition of computer networks, it's time to see when computer networks was invented. So in the next lecture, we will talk about history and applications of networking.